Hello friends, welcome to Physics Live channel. Today we are studying about the complex analysis second class. Okay, so we have already studied about this magnitude and representation of a complex number and the hyperbolic, how to change hyperbolic of sine and cos x like that, and we know how to separate the imaginary and the real part of the complex number. Next we have studied in this class, that is analytic function. Analytic function. So analytic function, if we said that a function is said to be analytic when it is a function f of z is analytic, means analytic when function is continuous and single valued. Continuous, the function should be continuous and single valued and differentiable at every point in the domain. Okay, so this is the conditions, that is the function is said to be analytic. The function is said to be analytic when it is continuous and single valued and differentiable at every point in the domain. So if you are considering a function f of z is equal to u of x comma y plus iv of x comma y, this is real part, this is imaginary part. Okay, so this is a function f of z is general representation, that is u of x comma y plus iv of x comma y. So the condition for analytic function, you know the conditions that is continuous and single valued and differentiable at every point, and there is one condition, that is Cauchy's Riemann condition. Cauchy Riemann condition, that is necessary condition, that is dou u by dou x is equal to dou v by dou y. Dou u by dou y, that's equal to minus of dou v by dou x. Okay, so this is the conditions followed by an analytical function. This is Cauchy-Riemann condition. This is necessary condition, and there is sufficient conditions are there, that is sufficient conditions dou u by dou x, dou v by dou y, dou u by dou y, dou v by dou x should exist. We know that there is exist. The derivatives of these should be exist, that is f dash z is exist. So this is the necessary condition, Cauchy-Riemann condition, that is you have to by heart this condition, that is dou u by dou x, that's equal to dou v by dou y, dou u by dou y is equal to minus of dou v by dou x. This is the Cauchy-Riemann conditions followed by an analytical function. These are the sufficient condition. Okay, so analytical function, a function is analytic when it is continuous, single valued and differentiable at every point in the domain, and there is a necessary condition, that is Cauchy-Riemann condition, and sufficient conditions there. Okay, so these are the questions we have to solve for this analytical or not. We have to check that is analytic or not. So first of all, we have to check the Cauchy-Riemann condition for these three functions, and we have to check that this condition is satisfied or not for these functions. If it is satisfied, the functions are analytic. So this is set cube, that is x plus iy whole cube. Okay, so x plus iy whole cube, that is x cube plus 3x square iy minus 3 iy all square, that is I square minus is there, and y square x I square, that is minus, and plus iy all cube. So that is x cube plus 3x square iy minus 3y square x I cube, that is minus I y cube. Okay, so we know that there is imaginary number is there, so we have to change the real part and imaginary part, that is x cube minus 3y square x plus I into 3x square y minus y cube. So this is terms real part and imaginary part of the function, and we have to check the Cauchy-Riemann condition for that. So this is u, this is v. So dou u by dou x is equal to dou v by dou y. Dou u by dou y is equal to minus of dou v by dou x. So we have to check this. So dou u by dou x, dou u by dou x, we have to differentiate this function with x, that is 3x square minus 3y square. Dou v by dou y, v is here, so y is 3x square minus 3y square. So the same, dou u by dou y, that is minus 3 into 2yx, that is minus 6yx. Dou v by dou x, that's equal to 3 into 2x into y, that is 6xy. So we have to check these conditions, that is dou u by dou x equal to dou v by dou y, that is 3x square minus 3y square. The two terms which gives the same, dou v by dou y and dou v by dou y and dou u by dou x, these are same. So Cauchy-Riemann condition satisfied. Okay, next dou u by dou y is equal to dou v by dou x minus of dou v by dou x. So minus 6yx, that's equal to minus of 6xy. So these are same in magnitude and there is only minus. So the condition dou u by dou y is equal to minus of dou v by dou x is satisfied. So this function is analytic. Z cube is analytic. Okay. Next we have to solve sin z. Okay. Sin z is the function. So sin z that's equal to sin of x plus iy. Sin a plus b is equal to sin a cos b. Sin x cos iy plus cos x sin iy. So cos iy, that is cos hy, sin x cos hy plus cos x sin iy is I sin hy, I sin hy. So this is real part and this is imaginary part. So dou u, this is u v, dou u by dou x is equal to cos x cos hy, dou v by dou y is equal to cos x cos hy. So dou u by dou x is equal to dou v by dou y. Okay, and dou u by dou y is equal to that is sin x cos hy derivative with respect to y, that is sin hy, and dou v by dou x is equal to cos x sin hy derivative with respect to x, that is sin hy with respect to x cos x minus sin x. So these are same and these are same in magnitude. So dou u by dou x equal to dou v by dou y. Dou u by dou y is equal to minus of dou v by dou x. It's satisfied. So this is analytic. Okay. Next we have to study z bar is analytic or not. So z bar is equal to x minus iy. So x is u, this is v. Dou u by dou x is equal to 1. Dou v by dou y is equal to what is v? V is y now, but minus y. Okay, so minus 1. So this is not similar, and dou u by dou y is equal to 0. Dou v by dou x is equal to 0. But these are not same, so it is not satisfied, and these are not satisfied, and this is not a analytic function. So these are the 3 questions we discussed here. That is, first of all, z cube. Z cube is x plus iy all cube. We know that a plus b all cube. How to solve it? And we separate the real part and the imaginary part, and we find that dou u by dou x equal to dou v by dou y. Dou u by dou y is equal to minus of dou v by dou x, and we get that z cube as analytic. And next question, that is sin z. Sin z is equal to sin of x plus iy. That is equal to sin of a plus b is equal to sin a cos b plus cos a sin b. From that we can separate the real part and the imaginary part, and we solve that is dou u by dou x and dou v by dou y, and we get that also analytic. And the next function, that is z bar, that is x minus iy, and we find that dou u by dou x and dou v by dou y, it is not same, so the Cauchy-Riemann condition is not satisfied there, so it is not analytic. Okay, so in this session you have studied about the complex analysis in which the analytic function, the Cauchy-Riemann condition, that is dou u by dou x is equal to dou v by dou y, and dou u by dou y is equal to minus of dou v by dou x. This is the condition we should remember for checking the function is analytic or not. Okay, thank you for watching and keep learning.